types or levels, classes of bees. You have the queen bee, who of course is by herself, and all she has to do is lay the eggs. You have the worker bees, which maintain the colony, keep it up to date, put in new computers, new software, etc., etc., etc. And then you have the drones, who will pretty much just do whatever. They're the men. Let's be honest. Like they're the ones that go out there and do what they got to do. But altruistic behavior in social organization is incredibly important as well, because their ability to socialize with other people helps them. Wolves, not guinea pigs, the things in Africa that stand up like this all the time, like they work together as a team in order to keep the majority safe. Somebody will squawk out, that squawker might be eaten, but the rest of the family is safe. So it's kind of taking one for the team again. I already know I said that, but just to reiterate. Let's move on to the nervous system. You have the automatic nervous system, which is very important, and that's basically, you don't have to think about it. You have parasympathetic nerves, and you have sympathetic nerves. Parasympathetic nerves are concerned with, bringing the body back down to homeostasis. This would be rest and digest, if you will. After, if you get any adrenaline sort of rush, like you relax after this as parasympathetic nerves are going off. Your heart rate decreases, your adrenaline decreases, your blood pressure decreases. The only thing that really increases is your digestion. Your pupils constrict because you're not trying to let in too much light. Sympathetic is pretty much the complete opposite of that. Your heart rate increases, your pupils dilate, your blood pressure increases, and that's when the adrenaline's rushing, and that's the fight or flight part of it, and you're trying to decide what to do. So let's move on to our last thing, is neurotransmitters and synapses. Now I'm supposed to sit here and state that synapses of the peripheral nervous system, which is everything but your brain and your spinal cord, are classified according to neurotransmitter used, including acetylcholine and noradrenaline. So that's pretty simple. Ta-da. Now I need to explain how the presynaptic neurons can either encourage or inhibit postsynaptic transmission by depolarization or hyperpolarization of the postsynaptic membrane. Now, I know that sounds complicated. Southern guy, podhead, this fella right here, the Russian, and I haven't really quite decided who this is, but it's okay, because I brought a friend along, and he's gonna pretty much explain it all to you. His name is Mr. Beaver. Say hello, Mr. Beaver. Hi, Mr. Beaver. Yeah, that's alright. Alright. So let's talk about how this works. Presynaptic neurons. Well, they can encourage postsynaptic transmission by depolarization of the postsynaptic membrane. It does not. Hold on, tongue-tied. It does this by causing sodium ions or other positively charged ions to enter postsynaptic neuron, helping to depolarize it and cause action potential. This is important because action potential makes neurons go. Don't forget that, children. Okay. This is called the excitatory synapse because it's excited. I know, it's fantastic. I love it. Anyways, presynaptic neurons can inhibit postsynaptic transmission by hyperpolarization of the postsynaptic membrane. This happens when negative chloride ions move from the postsynaptic neuron, increasing polarization. This is called hyperpolarization and makes it more difficult to polarize a neuron sufficiently to cause action potential. These synapses are called inhibitory synapses. Oh, geez, thanks, Mr. Beaver. He is a smart guy. He went to Duke. I don't know why I chose Duke. That was a bad idea. Now, I'm supposed to outline how pain is sensed and how endorphins and something else that starts with an E can act as painkillers. Basically what happens is pain receptors are located, in your brain, your skin, your organs, everywhere. And they sense pain, heat, pinching, blood, etc., etc., etc. These are sent along the nerves, pew, 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 until they finally get to your head. Now when they get to your head, that's when your brain finally says, ow. Move your hand, idiot. So you do that. However, in Felin's the one I can't spell or pronounce, is a painkiller used in Advil, etc., etc., etc. Meow, meow, meow. What it does is it blocks the synaptic transmissions, and that doesn't allow for pain receptors or pain neurons to fire off. So the you feel only gets to say here and not all the way to here, so your brain can't deduce that you're being hurt. Parkinson's disease is sort of like a giant. No, it's not anything like that. Parkinson's disease is very serious, and dopamine is actually involved. Basically, what happens in Parkinson's, for those who don't know, Michael J. Fox has it. You know, he can't stop shaking. You can't. Once you get to a certain point, you can't speak. You know, and basically your body just shakes uncontrollably. And that's because you have a lot of death of neurons in certain parts of the brain, and that part of the brain is the substantia nigra, and these neurons are the ones that release dopamine and control muscle contractions, which is what dopamine does. So if you don't have that ability, your muscles begin to contract uncontrollably, you become shaky, frustrated. You're just as capable mentally, but you can't control your body, which is why it's such a frustrating disease. Psychoactive drugs are an interesting subject, and they affect not only your body, but your behavior as well. So I'm going to let this guy go ahead and take this one away. Alright, bro, so let me just explain psychoactive drugs to you. And basically, they're like totally bad, like they mess with your brain and their personality and stuff. Okay, so for instance, alcohol. Whoa, whoa, whoa. I know you don't drink it, stuff like that. Like it's really bad for you, blah, 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 meow, meow, meow. So, like, alright, if you're at like a party, you know, and somebody's like falling over, it's because like their neurons aren't firing off fast enough and they're like, whoa, you know, like, whoa, and they like start falling and all this crazy stuff, and you know, it's just pretty cool. But it's not cool at all. It's not. Like, don't do it. It's really bad for you. But, like, for people who, like, snort crack, or, like, cocaine, or, like, speed and stuff, like, no. Like, whoa, that's really bad. But that's, like, an excitatory drug, you know? Because, like, your synaptic transmission and stuff, like, just starts, like, bam, 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 like, going off, like, so fast, and you're just like, well, gotta do something, blah, 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 like, gotta do something. Sometimes, like, you start to shake, like, you have so much synaptic neuron transmission, it's like, whoa, like, I'm doing way too much. But, like, it's super serious, like, your family, like, they'll start to, like, hate you, and, like, you're gonna start feeling weird, and, like, everybody's just gonna treat you differently, you know? It's like, all of a sudden, like, the world's out to get you. Like, the man stuff. You know what I mean? Like, the government, like, wow. Yeah. The government totally out to get us. It's crazy. Huh. Anyway, but there are way more many drugs that you might even be addicted to and you don't really even know it, that are excitatory drugs. Nicotine, if you smoke, which I hope none of you do, that's an excitatory drug. Caffeine. I'm sure every single one of you has had some sort of caffeine, whether it be in the form of coffee, tea, 5-Hour Energy, Red Bull, etc., etc., etc. That's a drug. That's an excitatory drug. It makes your neurons go off faster, and it affects your behavior. You feel a rush of energy after you drink coffee for that reason. You know, you may accomplish more, you may accomplish less because you end up going out and doing something different. But inhibitory drugs, such as cannabis and alcohol, are probably, I would say, more dangerous behaviorally. Over time, everything's bad for your body, whether it be cocaine or whether it be weed. They're all bad for your body, but for a one-time basis, and when it comes to like operating vehicles and things like that, cannabis and alcohol slow down your neuron transmission, which is bad because that means you won't see